All right, we're back. So direct variation problems. One of the most common applications of direct variation is the formula D equals RT. That is, the distance D varies directly as time, and the rate R is the constant of variation or the constant of proportionality in these problems. So basically, we're using D instead of Y, R instead of K, and T instead of X. And also the formula D equals RT means distance equals the rate times time. Again, I always like to use this. If you're driving down the highway at 50 miles per hour for 2 hours, if you do distance equals rate times time, your rate is 50 miles per hour, your time is 2 hours. You could figure out easily how far you've went. 100 miles, 50 times 2. Okay? The distance a jet travels varies directly as the number of hours it flies. There's that phrase, varies directly. So we know it's going to be y equals kx, or in this case, d equals r times t. A jet traveled 3,420 miles in 6 hours. Write a direct variation equation for the distance d flown in time t. So I know the distance equals rate times time. Here the distance is 3,420. The time is 6. So I have 3,420 equals r times 6. Divide both sides by 6, and you get r equals 570. That's the value of r. That's not the answer to this problem. The direct variation equation is d equals 570t. What that means is that the airliner flew at a rate of 570 miles per hour. If I want to graph that, I just draw a graph of d equals 570t. I plot the origin, and then I actually go up 570 points and over 1. Okay, so you're going to have to really change the scaling of your graph when you do this. Notice we made the y-axis or the d-axis go by thousands, and then the time graph go by ones. So if I go up 570, that's a little bit more than halfway to 1,000 over 1. Okay, and then the 0.6 comma 3,420 would be right about here. And that's actually the point that they gave us. All right, estimate how many hours it will take for an airliner to fly 6,500 miles. So if I know the distance, I can just plug that into my direct variation equation, divide by 570, and get t equals about 11.4. So in the context, 11.4 is the time, so that means that it would take the airliner approximately 11.4 hours to fly 6,500 miles. All right. All right, here's one for you to try. Go ahead and pause the video. Now, they don't tell you actual details in the setup to the problem. You have to look at the picture to pull off the information. I'll just give you that kind of hint there. All right, hit pause and then play it when you're ready. Okay, we're back. So part A, write a direct variation equation for the distance d ascended. So d equals rt. The distance is 350 equals r times 5. Divide both sides by 5. Now, here's how I do 350 divided by 5 in my head. I pretend the 0 is not there and think 35 divided by 5 is 7. So 350 divided by 5 is 7d. So d equals 70t. So if I graph the equation, I'm going to take this one by 1s and this one by 50s. So the second one would be 100, 200, 300, 400. So here's my origin. And I know that after 5 minutes, it should be up here at 350. So that's my line right there. Now, I'm not going to make the line continue in this opposite direction because in the context, it doesn't make sense. Because you're not going to go negative time and you're not going to go negative distance. 0, 0 does make sense. That's like before you took off, you hadn't risen at all. So you're still, no time has gone by and no ascension has, no distance has been traveled yet. Okay? All right, estimate how many minutes it would take to ascend 2,100 feet. Oops, somehow I got on arrows. So 2,100 equals 70t. Divide both sides by 70. And you get t equals 30. Again, I did in my head, I did 21 divided by 7 is 3, but it was 2,100 divided by 7D, which would give you 30, not 300, not 3,000 or anything like that. So it would take 30 minutes for the hot air balloon to ascend 2,100 feet. And part D, about how many minutes would it take to ascend 3,500 feet? So 3,500 equals 70T, divide both sides by 70. Again, I'm thinking 35 divided by 7 is 5. Slap a 0 on there. You could actually, you know, when you're dividing by numbers that end in 0, you can literally chop off the amount of common zeros. Basically, when you're chopping off zeros, you're reducing by a factor of 10. So if you take off 1 0 from each, it's like you're dividing the numerator and denominator by 10. If they had 2 zeros in common and you chop both of them off, that'd be like reducing it by a factor of 100. So this means that it would take about 50 minutes for the airplane to ascend 3,500 feet. All right, my mathematicians, that's it for this section. You take care, move on to your assignment, reach out to me if you have any questions, and make it a great day. Take care.